All right, in statistics, we're looking at measures of central tendency, which is your mean, median, mode. All right, first we're going to look at some graphs of distribution. And on this one here, notice that most of our entries are right here because we have a big cluster of values right there. But then it tapers off to the right. This is what we call positively skewed because it's got this little tail that goes to the right where the values are higher than what the big cluster is. So this is what we call positively skewed. Let's see what it's not symmetric. Symmetric would be something where you would have maybe values like this, where you kind of have maybe a center point and they're kind of symmetric on each side. This would be symmetric. The shape of the distribution is skewed left. Now this is skewed right. Skewed left would be like if this was reversed and the tail was over on this side. So I'll just draw like a line. It'd be something to look like this maybe, or the tail's over to the left. The shape of the distribution is uniform. Uniform would be like if you have maybe everything's the same, like that. The shape is skewed right. This is what it is right here, D. D's what we have. It's skewed right. And then E says it's none of those. Well, it's D. It's skewed right. Now here's one here. We see this picture here. Now this one looks like it's more symmetric. You can see here we have sort of like a central point that we could cut it down, and the left would look like the right, sort of. It's symmetric. So let's see here. It looks like D here. The shape of the distribution is symmetric. Okay, but not uniform because a vertical line can be drawn down the middle, creating two halves that look approximately the same. So that's what we have right there. All right. There's a couple more on this one. This looks like it's uniform because they're all about the same. Right here, A. And then number 4. Yeah, see, we got our tail over here to the left on this one. So this is skewed left, which is negatively skewed. If it's skewed to the left, which the values are lower than the cluster. Here's my cluster here. The values to the left, that's skewed left, which is negatively skewed. Okay. And number 5. Consider a frequency distribution of scores on a 70-point test where a few students scored much lower than the majority of the students. Match the distribution with one of the graphs shown below. All right, so the key here is a few students scored much lower than the majority. So you have a big cluster of majority, and then you have a few that scored lower. So that looks like about right here. So you got your majority right here, and then you had a few that scored lower, which is negatively skewed. So this would be C. This would be C. All right. All right, then we're going to get into some data then. We see these numbers here. Now, before we start on this, we're just going to go ahead and arrange them in order because that kind of makes it easier. So we have 4 looks like the lowest. So we have 1, 2, 3, 4, 5, 6, 4. So 4, 4, 4, 6 of them. All right, then we got 5. Now what I like to do is just go ahead and mark those out because we already got those. Now we have 1, 2, 3 5s. Then we have a 6. Then we've got a 7. Then we got 2 8s. And there you go. There's all my numbers written out. Okay, that was an 8 right there. It says find the mean. All right, the mean. Now let's go ahead and tell this. We've got two kinds of means. We have what's the population, and then we've got a sample mean. Remember now, population, that's like everybody in the population. So like if you have a business and you have all these workers at the business, every worker, that would be your population. Or if you're talking about a county and things in the county, well then everybody in the county would be your population. All right, the population me is this Greek letter called mu. And mu is going to be the sum, which remember I told you before, this little letter here, this is a sigma, which means it's the sum of all your x's in this population, divided by the total number, which is a capital N. That's the total number of your population. So if we're talking about the county, this is everybody in the county. So it's the sum of all your values of these people, whatever your data is, like here's all these values here, divided by how many people there are. The sample mean, we use X bar to represent the sample mean. And it's the same thing. It's the sum of all your values divided by the total number, but we use lowercase n here. Oh, I don't have it on there. We use lowercase n for that. So this is a population mean, and this is a sample mean. Now I would say this right here. This is the number of credits being taken by a sample of 13 full-time college students. So this is a sample. So we're looking at a sample mean here, which is X bar. So basically we add up all our x's, so we just add up all these and we divide by the number of them, which there's 13. So we add all these up. So here's what you do when you add them. This could make it easier, and you could go 4 plus 4 plus 4 plus 4 plus 4, just add them all up. What you can do though is, since there's 1, 2, 3, 4, 5, 6 fours, you can just go 6 times 4 plus, and then do your 5s. It's 3 times 5 plus a 6, and then we got plus a 7, and then plus 2 times 8. And there you go, it's 68. So the sum, let's see here. So the sum of your x's divided by n here, that's going to be 68 divided by 13. And so we just go divide by 13, and then bang, right there, 5.23. Okay, now you have to read this stuff right here. It says type an integer or a decimal rounded to 1 decimal place. Round to 1 decimal place. Okay, so this is just going to be 5.2. The 3 here does not make the 2 go up, so it's 5.2. Okay, so don't get all confused by this sigma and the mu over here. Don't get confused by those. This is just mean. We're just adding these up and we divide by how many there are. Just real simple. We add them all up, which is 68. If you don't like doing it how I did it here, you just add them up. I mean, you just go 4 plus 4 plus 4 plus 4 plus 4 plus 4 plus 5 plus 5 plus 5 plus 6 plus 7 plus 8 plus 8, and it's 68. So if you just add them up, you get 68, and there's 13 of them, you divide by 13. Real simple. You've been doing this for a long time, I'm sure. Does the mean represent the center of the data? Now, sometimes your mean may not, depending on what the circumstances are, but most times your mean is the center of the data, and it is here. See 5.2, if you look at all this, 5.2 is in the center of this, so this does represent the center. Find the median. All right, the median, now they have to be in order to do the median, so we've got these in order. And what the median is, it's the middle number or the average of the two middle numbers. Now, fortunately here, we've got an odd amount of numbers. We've got 13 numbers, so there is a median here. All right, so since there's 13, if I divide that by 2, 13 divided by 2 is 6.5. So that means the seventh number should be the middle one. 1, 2, 3, 4, 5, 6, 7. Should be this 5 right here is the median. And if you notice, I have 6 numbers on this side, and I have 6 numbers on that side. So there's my median right there, 5. So my median is 5. Okay. All right. Does the median represent the center? Okay, that's what we have next here. Does the median represent the center? Well, yes, it does. See, 5 is in the center there. So yes, it represents the center. Okay, find the mode. Now, the mode is what you have the most of. So if we look at this, we have the most of 4s. Okay, so the mode is 4. Okay, now does the mode represent, now this says does, do, mode, modes. Now you could have 2 modes. Here we just have 1 because clearly there's 1, 2, 3, 4, 5, 6 4s and there's not 6 of anything else. So 4 is what we have the most of. Sometimes you could have 2 modes, so that's why it has these little parentheses. But does the mode represent the center of the data? In this one, it does not, because it's the lowest value. See, 4 is the lowest value of all the data, so it does not represent the middle. And right here, B, because it's the smallest data value. Okay. Number 7. Find the mean, median, and mode of this data. Okay. So we have 7 entries here, so let's put them in order. All right, we always want them in order, so we'll just do that first. So looks like we got 9.6 and then 9.7. So let's mark those out. Next we have, what is it, 10.6? All right, then we have 11.0. Then we have 3 11.3s. Okay, and we write them in order because when we add them up, it's easier to tell. Like, see, I have 3 of these, so I can do 3 times that when I punch it in. So when I do this now, okay, so I'm going to go 9.6 plus 9.7 plus 10.6 plus 11 plus 3 times 11.3. Okay, and that's 74.8. So I get 74.8 when I add them up. Now I'm going to divide by, what was it, 7? 1, 2, 3, 4, 5, 6, 7. So I'm going to divide by 7, and I get 10.6857, whatever. Okay. Now you have to read on here, round to 1 decimal place is what it says. So 10.6, does this 8 make the 6 go up? It sure does, 10.7. There's my answer. Now, does this mean represent the center of the data? Well, yeah, it is the center of the data. In fact, 10.7 is this right between these two right here. So yes, mean represents the center. Okay. Now, what's the median score? The median. All right, it's the middle number. Fortunately, here we've got 7 of them, so we take, all right, so we do 7 divided by 2, which is 3.5. So that means the fourth number is the center. So 1, 2, 3, 4 right here. There's my center, 11.0. So the median score is 11.0. Okay, or you can just put 11. You don't have to put the 0.0. Okay. Now, does that represent the center? Yes, the median does represent the center. All right, now we're looking at the mode. What do we have the most of? So if you look at our data here, we've got 3 of those. That's the mode, 11.3. So my mode, 11.3. Does that represent the center? Well, no, it's the highest value. So right here, it's the largest value. So C. Okay. All right, we're going to move on from this one. That's the same thing, and this is the same. Just for extra practice, there's a few of these. Let's look at number 10 here. Okay. The class levels of 31 students in a physics course are shown below. Find the mean, median, mode of the data, if possible. Okay. So we have 3 freshmen, 12 sophomores, 9 juniors, and 7 seniors. Find the mean. Okay. Find the mean of this. All right, well, here's one where we cannot calculate the mean. It's not because there's too many sophomores. It's because right here, the data is at the nominal level. Okay. These are just titles at the nominal level: freshman, sophomore, junior, senior. They do have numbers, like freshman is 9th grade, sophomore's 10th grade, but this is just nominal level data. So this is C. We can't really find the mean of this. Now, does the mean represent the center of the data? Okay. Right here, the data set does not have a mean, so that's E. Okay, get it on the screen there. It does not have a mean. What about the median? Okay. Let's see here. The median, let's look through here. Right here. The median cannot be calculated because this is at the nominal level. Does the median represent the center of the data? Let's see here. Right here, the data does not have a median. Okay, there's no median because these are at the nominal level. Now, what about the mode? Okay, if you look at our data here, now we do have a mode. What do we have the most of? It looks like right here, sophomores. We got the most sophomores. So this does have a mode. So, okay, sophomores right here. This is my mode. Now, my paper here, the question ran off into the next part here, so let's see if we can put this together here. Okay. Does the mode represent a typical or central data entry? Okay, on this one, it is yes. It is a typical data entry because that's like, you know, this is typical what you're going to happen because you got more sophomores. So that's the typical, like the most common, maybe a common value. So that's what your mode would be. All right, number 11 here. And we've got this little pie chart, and we've got all these data here. What this is, the pie chart shows the responses of a sample of 330 small business owners who were asked whether their business has a website. Does your business have a website? Yes or no? Find the mean, the median, the mode of the data if possible. If the measures cannot be found or does not represent the center of the data, explain why. Okay, so find the mean. All right, well, this is a yes or no question. If you have internet or not. Okay, so it cannot be calculated because right here, it's at the nominal level again. Right there it is. Cannot be. See, all these say cannot be calculated. We cannot calculate the mean, so you just got to look through these, and it's at the nominal level here because these are nominal values. If you remember this from chapter 1, nominal. Okay. All right, does the mean represent the center of the data? Choose the correct. All right, well, it does not have a mean, so that's E. Okay, it does not have a mean. Find the median. Okay, again here, the median cannot be determined, so we can't do this because that's the nominal level, so that's D again. Okay. Does the median represent the center of the data? All right, well, it does not have a median, so that's this. Okay, so you can't have a median sometimes. Now here, you got to find the mode. Okay, well, let's go back up here and let's look at our data here. What do we have the most of? And it looks to me, right here, 136 is the biggest number here, and there's 136 that say yes since 2014 or earlier. So, right here, yes, since 2014 or earlier. That would be my mode. Okay, and then there's one more question in there. Does the mode represent a typical entry of the data? Yes, this is a typical entry, so right there, A. It's a typical entry because that's like the most common, the typical answer here. If you look at the pie chart, you see there's more of them than anything else. You can see how it looks on the pie chart. Okay. Now here's a good one. The weights in pounds of packages on a delivery truck are shown in the stem and leaf plot. Find the mean, median, and mode of the data, if possible. If any measure cannot be found or does not represent the center of the data, explain why. All right, so we have, here's our key here, 3/0 is 30. All right, so we have, this is 4, this is 8, this is 10, 12, 13, 19, 21, 23. So we have to add all these up. Okay, so let's get my calculator here. So we're going to do, we got 4 plus 8, whoops, not times, 4 plus 8 plus 10 plus 12 plus 13 plus 19 plus 21 plus 23 plus, all right, look here, I got 3 24s here, so plus 3 times 24 plus, then I got 2 28s, so 2 times 28 plus 30 plus 31, okay, plus 33 plus 35 plus, and then look here, I got 3 36s, so plus 3 times 36 plus 37 plus 38 plus 40 plus 41 plus 44 plus 45 plus 48 plus 52. There you go, 819. Okay, now typically I would do this twice, 819, but for the video purpose I'm just going to do it once. But when we add up a bunch of numbers like this, we always want to do it twice to make sure that we've done our work correctly. Now if you look through here, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28. There's 28, so I divide by 28. Okay, and that comes up to 29.25. Okay, round to 1 decimal place as needed. So this 5 makes the 2 go up to a 3. So 29.3, and this is correct. This is correct. Now, does the mean represent the center of data? Well, yes, it does. 29 falls in right here, which is in the center of all the data. If you look at this thing sideways, it kind of looks like this sideways. See, if you kind of look at the curve here, so it looks like it's symmetrically distributed. So So this is yes, A. The median, okay, the middle number. Now, when you have a stem and leaf plot, to find the middle number, as we just said a while ago, there's 28 of these. So when you do 28 divided by 2, it comes up to be 14. So that means it's going to be the 14th and the 15th numbers, and then I got to divide that by 2. So I got to add these together, the 14th and the 15th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 are those two. Okay, now you can double check it this way. So before this 0, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then after the 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we got 13 on each side of those two numbers. So I just take these two numbers and I add them together. Now remember, this is 30 and 31. So I do 30 plus 31, which is 61. And I divide that by 2, which is 30.5. So right there's my median. Okay. So the median, 30.5. Okay, does the median represent the center of data? Yes, it does. So right, that's A. And then the mode, where we have the most of. Let's go look at our data again. And remember, we had 3 4s here, so that's 24. And we had 3 6s there, so it's 36. So it looks like we have 2 modes here. We've got, what was it, 24 and 36. Okay, 24 and 36. All right, now we got 2 modes here, and we got the papers. Get this thing fixed up here. Okay. Now, since we've got 2 of them here, do the modes represent a typical entry of the data? All right, they do represent typical entry because that's like where we have our cluster at. So, A, the modes do represent a typical entry of the data. So that's a typical value. Okay. Now here we've got the same thing with the little dot plot. The dot plot of time in minutes it takes employees to drive to work is shown below. Find the mean, median, and mode of the data. If any measure cannot be found or does not represent the center of data, explain why. Now, just looking at this right here, you can see there's like a big cluster right here. And then you have a couple this way and a couple this way. But this kind of looks like it's evenly distributed, like it's symmetric down the middle. It's like we could draw a line down the middle here, and this half over here would kind of mirror image that half. But the mean, we're going to have to add these up. So, all right, so I'll get my calculator here. And we have a 5 plus, there's an 8 plus, and then we've got us a 12 plus, and then we've got 3 16, so 3 times 16. All right, so to speed this up, I just wrote the numbers down, and I added them up, which comes to 299, and I divide by 15, and when I did, I get this right here, 19.933, and it says type an integer or a decimal random to one place, so 19.9. The 3 does not make the 9 go up, so 19.9. There's my mean. Okay, does it represent the center of the data? Yes, it does. Right here, C. Okay. Find the median. All right, there's 15 of them, so if you do 15 divided by 2, that's 7.5. So the eighth one is the median. So 1, 2, 3, 4, 5, 6, 7, 8, right there, 20. 20 is my median. Okay, does it represent the center of data? Yes. Right here, D. And then the mode, what do we have the most of? Well, it looks like 16. There's 3 of those. Look at your dot plot. Yeah, there's 3. So 16 is the mode. Okay. And then it says down here, does the mode represent typical or central data entries? And yes, it does represent typical data entries right here, B. Okay. All right. Going to 14 here. This is a, all right, now this is a weighted mean. Okay, and this is what you have in your classes. You have your scores on homework, quizzes, then you got projects, and you got the final exam, and they're weighted. So like this is the percent of each grade. So basically what we're going to do is we're going to do 85 times 0.15, or 84, I'm sorry. All right, 84 times 0.15 comes out to 12.6. Then I do 87 times 0.05 now. So 87 times 0.05 is 4.35. Then I've got 92 here on the quiz. That's 5%. So I do 92 times 0.05 again. That's 4.6. Then I'm going to do 96 times 45% here. So 0.45. 96 times 0.45. That's 43.2. And then I've got 30% of the grades is final exam, so I do 85 times 0.30, and I get 25.5. And now I add all those up. All right, so let's 12.6 plus 4.35, oops, plus 4.6 plus 43.2 plus 25.5. This is 90.25. Okay, and that's my grade right there. Let me check my answer here, make sure we got the answer right. And right there, see, 90.25. So that's my weighted score. Okay. For the month of April, checking account has a balance of $522 for 23 days, $23.75 for 2 days, and then $262 for 5 days. What's the account's mean daily balance? Now this is what they do to charge you interest or to give you interest. They use your daily balance, which is your average daily balance. So, oh, excuse me. So basically what we're going to do is we're going to take 522 times 23. We're going to do 2,375 times 2. They're going to take 262 times 5. All right, so 522 times 23. That comes up to 12,006. 2,375 times 2 comes up to 4,750. Then 262 times 5 comes out to 1,310. So I add these up. Okay, so put it where you can see it better. So I got the 1,310 on there plus 4,750 plus 12,006. And so there's what I get my total for all the whole month. Then I got to divide by, there's 23 days here, 2 days is 25, and another 5. This is a month of April that had 30 days. So you just divide that by 30, and then there's your average daily balance, 602.20. And that's what the bank does when they give you interest on your account, if you have interest. So 602.20, that's your average. The mean scores for students in a statistics course are shown below. What's the mean score for the class? So again, we got 9 of these, we got 5 of those, we got 13 of these. I'll multiply those together, multiply those together, multiply those together, and then I'll add them just like we did here. And then I'll divide by the total, which is 9, 14, there's 27 total students. And so I'll let you do that one. I'm going to go this next one here. This is one we have in our college classes, finding your grade point average. Okay, so A is worth 4 points, B is 3, C is 2, and a D is worth 1 point. So if you make a B in 3 4-credit classes, all right, so 3 4 credits, that's 12 credits. So you got a B there, which is 3 points. So I do 3 times 12, which is 36. Okay. Then I have an A in 1 3-credit class. 1 3-credit class, that's 3 credits. And I've got an A, which is 4 points. So 4 times 3 is 12. All right, I got a D in 1 2-credit class. Well, 1 2-credit class, that's 2 credits. So D is worth 1 point. So 1 times 2 is 2. Then I got a C in 1 3-credit class. Well, 1 3-credit class is 3 credits. So a C is 2 points, sorry. So 2 times 3 would be 6. Okay. So if I add these up, that's going to be 56. Okay. Yeah. 14, get 56. So if I add up all my total points, comes up to 56. Now, how many credits was I taking? Okay, there's 3, 12 is 15, and 5 here is 20. There's 20 total credits. So I do 56 divided by 20. So 56 divided by 20 is 2.8. So this is your GPA, your grade point average. That's how you calculate them. You figure out your total credits. So 3 4 hours is 12. This is 3. These are total credits, which comes up to 56. I'm sorry, which is 20. And then your points in each credit, you add those up, which is 56. So the points for your credits divided by your credits, 2.8. Okay, we're about to finish up here. This is a frequency distribution. Okay, so we have this class, and there's 29 in that class, there's 22 in this class, and then so on. Okay, we want to figure out what the approximate age is, or the approximate mean age, the average. All right, so what we're going to have to do is we're going to have to find our midpoints. So remember, 9 plus 0 is 9, divided by 2 is 4.5. So this is a 4.5 midpoint. Okay, right here, 10 plus 19 is 29, divided by 2 is 14.5. And it looks like these go up by 10 every time, which you see 0, 10, 20, 30. They go up by 10. So all right, so to speed it up, I went ahead and found my midpoints from 0 to 9. 9 plus 0 is 9, divided by 2 is 4.5. 19 plus 10 is 29, divided by 2. And I went through there and got all my midpoints. And I got to take my midpoint times my frequency. So there's 29 of these, so 29 times 4.5 is this. 22 times 14.5 is this, and so on. So I got all these numbers here when I do my frequency times my midpoint. Okay, well, to find the mean of the frequency, I add all these up, and I got 99, 36, and I add up my total frequency. There's a total of 228 of these, and I divide those, and that's my approximate mean. Now it says round 1 decimal place, so 43.6. All right, so you find your midpoints, take your frequency and multiply those, and then add all these up, add up your total frequency, and divide them. Okay, here's another one here. We got some data here, and we put them in our classes, so we got our frequency, so I went ahead and counted those up. There were 7 of these, there's 6 of those, and so on. And these are the numbers of the frequency. All right, well, wants to construct a histogram of that. So I believe that's going to be this one here. I think it's this one, because see, we have 7 of these, and then 6 of those, and 3, 3, and then 1. So here's my histogram right there. Okay, and it's wanting to describe the shape of it. Well, it's got a tail to the right, which means it's positively skewed. So it looks like B here, positively skewed. Your tail is over to the right. See here, most of your data is here, and it's got a little tail to the right. All right, so I think we've pretty much done everything here. Measures of central tendency. So if you need any help, just give me a shout, okay? I'm here for you. Have a good rest of the day.